Hello and welcome to this webinar presentation on net zero hospitals. My name is Frank Mills. I'm Chairman of the Institution of Mechanical Engineers Construction and Building Services Division and also Chairman of the CIBSE Healthcare Group. I've got a background in healthcare which I've summarised on this slide. I've been involved in energy and low energy hospital studies since 1981. When we look at the modern hospital in the UK and across the world, there are some fairly big drivers for change at the moment. Obviously, there's financial targets being set because hospitals cost a lot of money to operate, and we are in an era of increasing costs, and there's great pressure to try and limit that. So there are issues to do with money which we must be aware of. There's also increase in healthcare demands. We have a growing population and we have a growing elderly population, so the demands for healthcare are increasing in all directions. There's new legislation being passed which requires hospitals to do even more, and of course we have government performance targets being set, so hospitals are being monitored very closely. We also have a climate change agenda which all buildings worldwide are having to respond to: rising sea levels, warmer summers, and other issues which are impacting on the way hospitals work. And in the UK we have heat and energy saving strategies, so that we're trying to reduce the amount of heat we use and reduce the energy consumption of hospitals. And there are broader sustainability targets set by the NHS. And overriding all of those things is a really commitment to improve the patient experience. The changing drivers looking at energy relate back to UK CO2 reduction targets, which were to be 80% reduction by 2050, but the UK government has now decided that target isn't sufficient, and we have to reduce by 100% to become a completely net zero carbon country by 2050. So that target is now out of date, and we're looking at building regulations which have stalled, in fact, but when first put together in 2006, we're looking to have all the buildings net zero by next year, 2019, including hospitals. And so you can see the progressive reductions that were set at each review of the regulations. So essentially the 2016 regulations did not come in, so that Part L is still awaited, and the 2019 version has not been issued either. So the actual step from that 44% reduction to net zero hasn't occurred. However, it will do at some stage. And I think we can see as we look around that there's lots of new buildings being constructed that are not actually net zero, and in some cases nowhere near it. So I think we can conclude at this point in time that the UK government has stalled on the Part L targets. However, there is this overriding commitment which I mentioned to become net zero by 2050. I think when we look at construction generally, there's a drive for modern attractive design, and that tends to outweigh net zero. Certainly from a developer's point of view and from an architect's point of view, we're looking very much at the appearance of the building and the way it functions, and energy is obviously not the primary concern, although it's something we have to deal with if we're going to become net zero. There's been various other targets such as in schools, which to some extent are an easier proposition. They're not occupied for the same hours as hospitals. They're only occupied, should we say, 9 o'clock in the morning till 3 o'clock in the afternoon, 5 days a week. So they should be a bit easier to become net zero. And this was a rota zero carbon issued by the government's Zero Carbon Task Force some time ago, seeking to become net zero by 2016, and that didn't in fact occur. Would have been a good idea because schools give you the opportunity for public engagement on energy and carbon. It becomes an awareness exercise. As we develop knowledge and skills, we can gain feedback on the performance of schools and share that with students and their parents. And of course it starts to influence how we have lower carbon energy supplies into industry. And we can look at investments and improvements onto existing buildings, and the schools themselves become living labs. Their visual impact on students who are obviously our next generation of engineers, architects and others. And the students themselves can monitor the targets of the schools to become very much aware of what we mean by net zero energy in construction. What has been happening more recently is that we're looking to cities to set their own agendas, and Manchester has come up with its own climate change strategy. And interestingly enough, they have also set a zero carbon target for 2050. As stated here, Manchester is playing its full part in limiting the impacts of climate change locally and globally. It is a thriving zero carbon, zero waste, climate resilient city where all our residents, public, private and third sector organisations are actively contributing to and benefiting from the city's success. Now that was interesting when it was issued, but since then they've had a Green Summit and they've actually started to look ahead of the government. This is Mayor Andy Byrne at the Green Summit setting a pledge that the target for the city to become net zero would in fact be 2040, not 2050. And he's looking to the citizens of Manchester to support this pledge and do their bit. Interestingly enough, the Manchester Tyndall Centre, based at the University of Manchester, is a world leader in climate change research and has really identified the year 2038 as a critical turning point by which we should really be net zero. So that's influenced Manchester greatly. And of course other cities are beginning to understand that, and you can see London with its own action plan looking to become net zero by 2050. So the background here is there is a big political desire and there's also a scientific push to become net zero as soon as possible, around the year 2038, 2040 ideally, but maybe 2050. And that of course is everything. It's not just buildings, it's transport and process, food, all the things that we use energy for need to be net zero in order to meet that target. So pondering upon that, we ask ourselves how are we going to be net zero when we look at cities like London. They certainly don't look as if they're net zero at the moment, they don't look anywhere near it. But that's the challenge in the next 20 odd years. Here's a map of London from the building centre, and you can see there's a lot of existing old buildings out there that are going to be very difficult to upgrade. Many of them listed, of course, so external insulation is a possibility. And then we can look at how we might go on to ask the question, can we achieve this in hospitals? At the present point in time, we have somewhat of a crisis in construction. We have the Renewable Tower disaster, which means we have to really look at the way construction works to improve ourselves, certainly in the UK. There's some confusion over Brexit, of course. In the UK, engineers are not actually registered as a profession, so the input by engineers is not a legal requirement, and engineers themselves are not have no legal status. Nor do we push for CPD to be mandatory as yet. Although our institution is requiring that, but it's not a mandatory requirement as yet. We do have certification schemes, but they are limited and ineffective. And I have noticed that building services courses are beginning to close around the country at a time when we probably need more and better building services. Industry leadership and management issues as companies begin to argue or collapse or even fail to deliver. Recently we had the large collapse of Carillion. And then of course we have other issues such as the poor care of historic buildings, fires destroying irreplaceable landmarks such as the Littlewoods building, Macintosh Library, Black Buildings, Belfast. So as an industry there are many problems. So how can we solve these and also make sure that we start to look at net zero for hospitals? The Hackett inquiry did indicate a way ahead. It was really an independent review of building regulations and fire safety based on the Renewable Tower, and it listed a number of specific areas. It looked at The roles and responsibilities of those procuring, designing, constructing and maintaining buildings felt that they were unclear, and this includes engineers who should have a controlling and supervisory role but lack status, and in fact often overruled by others who are non-engineers. They felt that the package of regulations and guidance, which are in the form of the approved documents, can be ambiguous and inconsistent. They felt that the processes that drive compliance with building safety requirements are weak and complex, with poor record keeping and poor change control. And they felt that competence across the system is patchy. They felt that product testing, labelling and marketing regime is opaque and insufficient. And they felt that, based on Grenfell, the voices of the residents, the occupants and users often go unheard, even when safety issues are identified. And I've noticed the same applies to energy usage, where occupants who may not be happy with high energy bills in the building they're renting or occupying have to pay the bill, whatever it is, and have a little power or authority to try and make the owner of the building make it more efficient. And then, of course, we find that integrated design and construction approach, which is the preferred way of taking construction, is not, in fact, the norm. When we do look at hospitals, and this is the Royal Victoria Hospital at Newcastle, you can see straight away that, unlike other buildings, they do use a tremendous amount of energy. They are packed with equipment, they have a lot of people in specialist environments, and they are being used 24 hours a day, every day of the year. So they are very high energy consumers. And in particular, they use very large amounts of electricity. So this is a challenge, really, is can we operate these buildings with the amount of energy they need in a zero carbon environment. Interestingly enough, when we look at UK hospitals compared to others, they use much too much energy. Surprisingly, they use more than United States hospitals. And I say that because the UK climate is a temperate climate. We do not have extreme summers or winters. So one would expect UK hospitals to be more efficient. The media UK performance is 68.8 gigajoules per 100 cubic metres. In hospitals, energy consumption is looked at on a cubic volume basis. Only 65% of hospitals actually meet the mandatory target set by the NHS of 65 gigajoules, and only 45% meet the target of 55 for new build and major refurbishments in hospitals. So at the moment we're failing to meet the targets that the NHS has set. And only 17% of the hospitals are less than 40 to 45 gigajoules per 100 cubic metres. I would conclude from those figures that UK hospitals use a lot more energy than necessary, certainly more than the target set. So the question is, what chance have we of getting down to zero on both new builds hospitals and existing hospitals by that date I mentioned earlier of 2040. This graph just indicates how the UK and the US compare, and you can see that set across these various dates of the year. The UK average was 68.8, the US average is only 45 gigajoules per 100 cubic metres, so much more efficient there in a more extreme climate. So in a way that does give us some reassurance that we can start to do better if we start to tackle the issues. This again compares the types of hospitals with the US average is there in red. I've put on top of that graph. It's a graph I've taken from the HCNs, and it shows for different types of hospitals how much energy we use for heating and for electricity. And again, we are projected over to the right in the UK, so we do use much more than necessary. I think hospitals can be net zero. How to do it. The size is not really an issue. The fact that big buildings doesn't really come into it. We can make big buildings or small buildings net zero if we take the right approach. The long hours of usage can actually be a benefit because there's internal heat generated by the processes going on by people themselves, and so we do actually have quite a lot of waste heat that we tend to reject. But if we to recover and store it, it could be a benefit to us. And of course, hospitals need a resilience, they need electricity backup. So more on-site generation, which give us more net zero heat energy available through combined heat and power and others, and also cooling through absorption chillers, will start to give us net zero heating and cooling energy. Looking at the size issue, this is actually a 13-story office block in California. It's the largest net zero energy building in the US, at a size of 415,000 square feet. It operates on a biogas fuel and on-site fuel cells. Methane to electricity, tapping methane in landfills and wastewater plants. And that's a net zero building which has been operating for some years now. Looks like a conventional office building. So they can do that in that climate. And perhaps a bigger example of what's going on is the Dubai Electricity and Water Authority's new headquarters, which they claim will be the tallest, largest and smartest net zero energy building in the world once it's completed in 2019. They are using total renewable energy generated by the building of 5,400 megawatt hours annually. And the design is inspired by their traditional approach, where enclosed spaces overlook open courtyards. So large buildings can be net zero if the right approach is taken. Looking specifically at how we might do it for hospitals, was the three-step approach, which could be applied to new build and existing. The three steps were to, first of all, reduce the demand in the building, so we had efficient operations wherever we could, and then reduce waste, so operated systems that didn't have much waste, or maybe we reuse the waste if it was available heat. And then we would install renewable energy systems such as photovoltaics, maybe a combined heat and power system, wind turbines, geothermal, and those energy systems would be net zero. And then, of course, by doing that, we would gradually reduce the use of fossil fuels and ultimately avoid them altogether so that we become decarbonised. So that was the three-step approach. But we're looking more likely at a five-step approach now, which has been developed by REVA. This was presented at the Klima conference in Aalborg in 2016, led by a Dutch engineering group. And their approach is, first of all, look at behavioural change, user demand and behaviour. There's a lot of things we do in hospitals which use energy unnecessarily. The first step is to deal with that. Secondly, we then look at reducing demand. After that, we then add the renewables we need to the building. And then we move on to a situation of having a no waste strategy. If we do have any available energy, such as heat, we store it and we use it when needed. We try and take an approach that is zero waste. And we use any fossil fuels that we are using efficiently, such as through combined heat and power. And this is five-step approach which is being developed at the moment by REVA and will be issued in a design guidebook. Now, there has been quite a bit of work here in the EU looking at how we might get energy and health down. So this particular project called Energy for Health looked at the demand-side policy roadmap and had stakeholder consultation. It was one of 6 projects being carried out in support of the Demand-Side Action Plan 2. Commenced in January 2014, concluded in 2015. And the aim was to develop a policy roadmap to influence the demand for innovative energy solutions in the healthcare sector. And it was generated through 4 activities, looking at a baseline scenario to 2020, creating policy action roadmaps for more favourable scenarios, engaging with influential stakeholders, and developing an implementation strategy. This set out a vision for 2025. The vision they had was that the European healthcare sector would become a global leader in energy efficiency and community renewable energy systems. That's an interesting idea there. The hospital is seen as part of a wider community, and by sharing its energy with the community, for example, combined heat and power, which would generate the large amounts of electricity that the hospital needs, might also make waste heat available, which could be distributed into the local community, and the hospital would take the benefit of that as a zero carbon heat energy, which is being distributed into housing or residential. The other part of the vision was to look at many becoming both carbon and cost neutral. So that's an interesting concept. It's not just the fact we go to net zero fossil fuel energy, net zero carbon, but actually the costs come down and could, in some cases, become neutral. The average cost of energy becoming 1% of the healthcare budget, that would be certainly good news on the financial front, and the sector becoming well on its way towards reducing its 2050 carbon footprint to less than 20% of 1990 levels. So actually not as ambitious as the UK policies we've heard about earlier. However, there are a number of key issues around that. A lack of comparable energy benchmarking data. There's limited access to finance and investment to get on with the things that are necessary, and actually a lack of knowledge transfer and skills development for energy. Because if we're going to do these things that are necessary, then we need to know what we're doing and be able to finance them properly and be able to compare what we're doing with what we currently use. Looking on the right-hand side there, there's another issue is the lack of recognition of the health impacts of energy choices. So the fossil fuel energy scenario does create a lot of pollution. We do have issues to do with health related to that. So it would be actually quite healthy to reduce energy anyway. There's a lack of strategic direction and incentives to address energy in healthcare, and there's ultimately a culture of risk aversion which limits adoption of innovative solutions. In other words, let's carry on doing what we've always done because we're not sure if the new solution will be a good one or work properly or be effective. So we do need to develop an innovative approach. Other projects that have been looked at in countries like Sweden is how can we do more with less by making better use of space. Obviously, in any hospital building, the amount of energy being used is dependent on the size of the place. So if we can use less space, we will save energy. So interestingly enough, for a typical hospital in Sweden, every 1 square metre of space saved translates into 200 to 250 kilowatt hours energy saving per year. In the UK, of course, the same amount of space saving would actually result in nearly twice that, 400 to 450 kilowatt hours a year. So the question is, how much space do we actually need to do the things that we do? And this particular project called Conclude, which can be looked at on that website there, conclude.org.uk, looked at actions which might achieve a target of less than 200 kilowatt hours per square metre. And the energy analysis demonstrated that right sizing of the space in the hospital and HVAC plant infrastructure, so obviously oversizing plant is another problem in terms of energy consumption, and this is based on using occupancy analytics data. The overall plant sizing could be reduced by an average of 24%, and energy consumption reduced to between 100 to 150 kilowatt hours per square metre. This is based on energy analysis modelling work, having been taken through to a practical stage, as far as I know, but it indicated massive savings really on both energy, size of plant, and you could conclude from that probably capital cost savings as well. When we look specifically at some of the things that we take for granted or we do as standard in the UK, we can see that they're not efficient. This is a diagram from HCMO3, which is the hospital ventilation standard, and it shows that we work really on a full fresh air system in operating theatres and like. And generally in the UK, full fresh air is the norm throughout a hospital actually. In other words, we bring in very cold air in winter, we heat it up, we filter it, we add extra heater to get the temperature we want, and then we distribute it into the various rooms that we're serving in and when we finished, we exhaust it all out of the building. We do not reuse that air, and the air change rates can be quite high. 10 air changes in treatment rooms, 20 air changes in operating theatres. So there's a lot of air that is being heated and then thrown away. And the same applies in summer when we cool the air. Bring the air in, we cool it to the temperature we need, distribute it, extract it from the rooms, and again throw it away. So if we were to recirculate some of the air, then we could actually save quite a lot of energy. However, it is not the norm in the UK. It is actually allowed by the latest version of HTM03, although it wasn't permitted earlier on. The last version before 03 was HTM 2025, which more or less prohibited recirculation of air. I thought I might show what we achieved here with a case study in the Northern Cancer Care Centre in Newcastle. This was an upgrade ventilation project where we installed a packaged air handling unit into each of the cancer treatment rooms. And the aim was actually to achieve higher air quality. So we used systems with a high efficiency filter, HEPA 14. We used 10 air changes an hour of recirculation and introduced between 4 to 6 fresh air changes per hour. That fresh air coming in through an F7 filter. The project was done to remove fan coils which had been installed, and this is a picture of the area in the ceiling above the treatment rooms. And you can see these are pretty hefty lead-lined rooms. They are involved in cancer treatment, and the fan coils were recirculating the air without any filtration, so they were removed, and the mini air handling unit installed with the HEPA 14 filters instead. The fresh air rate reduced to the 4 to 6 air changes that I mentioned. It was a major refurbishment project, and the approach which was proposed was approved by Public Health England, and I think the net result is that these are probably the cleanest treatment rooms in the UK now. They're recirculating 10 air changes of air through HEPA 14 filters, and they also have 4 air changes minimum of fresh air coming into the rooms. At all times, the patient environment was the priority. The air quality and indeed the internal environmental quality had to be the best. But the machines themselves operate between strict limits, so airflows are critical for the equipment as well as the patient. So one of the issues which shows maybe the culture is that the HVAC systems are running at full capacity 24 hours a day, 7 days a week, even though the rooms themselves are operated for 10 to 12 hours a day, 6 or 7 days a week, depending on their workload. Referring to the Health Technical Memorandum 07, which is the latest version of Encode, it describes how we might make energy work in healthcare, and it really takes us through the legislation which ensures that top of their Parliament is passing various laws and requirements for us to reduce energy, which drive down through the building regulations. But in the case of hospitals, we also have our NHS and Department of Health setting requirements. At the end of the day, we're looking for improved patient outcomes in terms of safety, effectiveness, and the patient experience, and patient well-being at all times. But we need to drive down through this, looking at that agenda for net zero hospitals. Looking at the more recent developments of hospitals, some of our latest PFI hospitals, we can see that we are moving in the right direction, although we have some way to go. One development which we do properly is natural ventilation. We perhaps are more effective in that than many other countries. So at this new hospital in Romford, which is a low energy district hospital, It's over 50% naturally ventilated. The new hospital, which was constructed, reduced the energy from the old figure of 101 to 58 gigajoules per 100 cubic meters per year. It incorporated lighting controls, a lot of heat recovery, daylighting with controls linked to the lighting systems, and control of glare and summer heat gains. So a very effective hospital. Queen's Hospital Romford was in fact the PFI hospital of the year some years ago, halving the energy consumption on the way. However, there were some things which happened which I felt were wrong at the time, and I think have proven to be so. The hospital included gas-fired CHP, which provided electricity and heat at very cost-effective rates, but the hospital also included 4 medium pressure hot water boilers, even though the building itself was operated 24 hours a day. So a lot of internal heat gain. It had a very low heating load because the new Part L at that time required the building fabric to be highly insulated and well sealed. Effectively, there was no real heat demand throughout the whole year, so actually no need for any boilers at all. In my visit back to the hospital, I'm told that sometimes one boiler is used. It's on low heat load, but never have more than one boiler on at once. So here's a situation where perhaps our experience with hospital energy centres is to put all this equipment in, because that's what we've always done. However, they aren't actually needed. So it can save money, save space, and save energy. Now, natural ventilation is in fact ideal for hospitals. It can't be used throughout the whole hospital, but it can be used in many areas, and as we've seen from various studies, it can be used up to 50% of the areas of hospitals. And of course, it gives us major energy savings, major capital cost savings because we don't use paper ventilation equipment, major operational savings because there's less equipment to maintain. It gives us improved infection control because fresh air coming in is seen to be clean air, improved indoor air quality, and increased patient and staff comfort. The Department of Health commissioned a study which was led by the University of Cambridge to how we might use natural ventilation to achieve low energy cooling and ventilation in the hospitals. And the study took the Romford Hospital, which I've just shown you as a standard hospital, if you will. It took those areas and replanned the hospital. It produced a ground floor layout, which you see there, which included all the rooms that require mechanical ventilation and air conditioning for close control. But it also included, linked in the bottom there, the patient blocks, which are naturally ventilated patient rooms. It then looked at siting on the first floor rooms which could be naturally ventilated, some rooms which still require mechanical ventilation and air conditioning, of course. But again, the patient block at the bottom end there being fully naturally ventilated and linked through bridges onto the main building. And on the upper floors, essentially all natural ventilation rising through to the roof level, so that the hospital itself had quite a lot of natural ventilation in it. And the study was carried out for that building to see what effect it would have and how much energy would be saved. This is a ventilation cross-section through the building, and you can see that by use of the courtyards, air is brought in through chimneys into the spaces at low level. It transitions across, rising through its buoyancy to higher level, and then exhausts through the chimneys out at high level onto the roof there. So we're talking about advanced natural ventilation, which permits airflows in at low level and out at high level, carefully controlled. And this study then came up with this result, and in fact there were some parts of the building which we had to air condition fully, but only 7%. There were some parts which needed a level of mechanical ventilation heating and cooling, only 12%, and then progressively moving through, we found that other areas needed just simple ventilation, and we could apply natural ventilation to 40% of the building, and 30% with automated controls. One of the hospitals which I worked on in 1991 was the Guy's Hospital extension, Philip Harris extension, which was completed with natural ventilation into these courtyards, and this allowed us to punch down into the hospital with spaces which allowed natural ventilation into adjoining rooms, and it permitted better daylighting, and also these plants in an area of London, just outside London Bridge here, which hasn't got much in the way of landscaping. These were pleasant areas within the hospital. I should also refer you to the World Health Organization publication of natural ventilation, which really looks to promote natural ventilation to achieve infection control in healthcare settings. So it's very supportive of natural ventilation as a way of improving infection control. And of course, our own document, HTM03, which is available from the Department of Health, sets out how we should be ventilating spaces, and in that talks about natural ventilation. So the UK guidance on ventilation is the HTM03, published by the Department of Health. Sets out the air change rates, temperatures and conditions for ventilation in hospital, and does advocate natural ventilation in many areas where possible. Other guidance on HVAC in buildings being published by organisations such as ASHRAE are helping us meet lower energy targets. So this is the ASHRAE guidance on grocery stores, which is a 50% reduction. These are available free online from ashrae.org and can be downloaded. And I mention that because it also looks at schools, which are a 50% reduction on the left, and there's a new document come out from ASHRAE which is showing you how you could design schools to be zero energy. And these are part of a series which include hospitals. So this is a guidance document on HVAC in hospitals, looking at a 50% reduction on hospitals, and work in progress is towards a net zero hospital, and that's design development work between ASHRAE and REBA, which I'm involved with. If anyone wants to be involved with this work, please contact me. But it's been led by a Dutch engineering group, and that looks to be published next year. Supporting that is the design standard ASHRAE Building EQ, which is looking at how we might make sure that buildings not only are designed and modelled to be net zero, but actually perform in practice. In the UK, we have the Energy Performance Certificate, which is a modelled figure, and with the Display Energy Certificate, which is the recorded figure on site. So it's a matter of avoiding the gap and make sure we actually achieve in practice. There's many technologies which we can apply. Combined heat and power is a good one, and I think the real opportunity with the hospital is to look at how we might install more generation plant, because hospitals need more electricity. They also need more resilience and backup, but to use the heat from that to not only heat and cool the hospital using trigeneration, but to allow heat to be pumped out into the local community and sold, of course. That, from a carbon point of view, is a method of offsetting any carbon that the hospital is using. And of course, I won't go into detail, but combined heat and power is extremely effective compared to our current electricity generation system, which wastes around 65% of all the energy that is installed into it. We must look at more renewable energy systems, of course, and there's scope for that, and some hospitals are applying that. And there are plenty of geothermal opportunities which we can start to apply in our hospitals. We can take heed from some of the work being done elsewhere. In Toronto, for example, there was talk of lake cooling some 20 to 30 years ago, but it's a project which has now in fact been completed. So Toronto as a city has zero carbon cooling from Lake Ontario. It's a major renewable energy system installed by a general contractor who's responsible for the procurement and construction of all the pipelines, and it serves the city. It's completed in fact in 2004 and is operating very successfully as a complete zero carbon system. And we have some similar opportunities over here. We want to take them up. This was an article in the press recently which said that our abandoned collieries have water in them. They've become flooded. The water is actually quite hot because the temperature underground is hotter. And if we were to start pumping that out, we could be heating homes free. And of course, we could be using that into hospitals. So the UK coal industry is closed down. Mines are flooded. There's a vast reservoir of warm water down there, filling a labyrinth of disused mines. This is a particular study for Glasgow, but the same elsewhere. And this subterranean store of naturally heated water could be used to warm hospitals and homes, and could be exploited across other cities where there's coal communities. So with that, I'd like to conclude by saying that there is a push to become net zero. And although hospitals appear to be big energy consumers and they're operating for long hours, there's a lot of technology that we can apply. There's a lot of design approaches which would help us to reduce the energy consumption, and it's certainly quite possible to build brand new net zero energy hospitals now and to progress with our existing hospitals to become net zero by that target date I mentioned earlier, 2050.
Right. So, hi. Well, thank you very much. That concludes the slide. So now open to any questions or discussion or comments that people want to put forward. Just while you're thinking about that, I think it's worth looking back at the issues here that are preventing us in the UK from going to net zero. It seems to be perhaps an attitude that we need to spend all the money we can on patient welfare and perhaps let the infrastructure slip a bit. And yet the evidence is showing us that the money well spent would actually reduce costs on the hospital and actually make more money available for patient welfare. And then I think you saw in that European Vision 2025 that aimed hospitals that use less than 1% for energy costs. So that would be a massive reduction and put a lot of money back into the patient care system. I think other evidence is showing that hospitals with the right environment are giving patients much better experience. And the Philadelphia Hospital some time ago looked at things, for example, like views and daylight, and found people leave hospital a couple of days earlier if their environment is attractive and nice and pleasant to them. So forget the temperature numbers, it's how they feel. And so they leave early. So are there any questions arriving yet? I think one of the big ways to get to net zero that I can see is that we get hospitals to join into these district energy schemes, which we're about to start in the UK. And if we can do that and deliver heat to neighbouring districts, it'll have two impacts. First of all, it would give hospitals much better electricity resilience, lower electricity costs, and really improve their electrical systems considerably. And then the heat that's generated, well, obviously could be used in a hospital, but presumably, or a lot of it would actually be used delivering outside into the district energy system of the town or city that the hospital's in. And once that's done, we can allocate the carbon savings towards the hospital. The hospital, in effect, is taking a credit for saving carbon in that neighbourhood, and that would go towards the hospital's carbon footprint, which would reduce their carbon considerably. So this is, if you like, offsetting to some extent. But rather than throw that heat away, deliver it somewhere else where it can be used properly, and then take the credit for that from a carbon point of view. I think the other area there is heat storage. So in all the work I've done on hospitals, there is actually enough heat being generated in the hospital to heat the hospital, certainly with a modern hospital, and we don't really need any heating boilers. I think Romford showed us that. I did the Romford analysis in 2002, 2003, and at that time the contractor was really following traditional practice of putting 4 large boilers in. And as we found, since the hospital has been finished, they hardly ever use one. So you could say a bit of a waste of money, but perhaps the backup's needed. But those boilers are oversized and don't, in fact, need to be used. So a different approach, a different cultural approach, which says there's heat being generated in the hospital, recover that heat, put it into storage, and when you need that heat, take it out of the storage and use it in your air handling systems or wet radiator type systems to give you heat. So I think that's the area where you would like to pick up available heat. And of course all that heat is zero carbon because it's just being generated by lights, people, equipment in the hospital, and use that to do the heating. Then you're able to take that as a carbon credit, of course. Now I have a question here. It says, thanks for the presentation. Does a lot depend on the location of the hospital in determining whether net zero is possible to achieve or not? And secondly, on efficiency of equipment, can that be improved? I think not. In the work I've done on hospitals, the actual energy consumption is similar across the whole world. It's really the major energy use in a hospital is the systems inside, the equipment, what people are doing. So whilst you would expect a temperate climate like the UK to use less energy, it's actually using more energy than American hospitals, which generally are in hotter climates in the south of the US and colder climates in the north and in Canada. But I think if you look at the energy analyses, there's a hell of a lot of energy being used in the lighting, the systems, the equipment, which are tending to be on 24 hours a day, 365 days a year. So yeah, obviously the climate does have an impact, but it's not the dominant factor. And really, in trying to get to net zero, we should be able to achieve that virtually anywhere in the world. Now, I'm tending to use the European definition of net zero here, which excludes things like plug loads, so MRI equipment, CT scanners, and all those kind of things are not being included in the carbon at this point in time. So any energy they generate, waste heat and the like, and we use that is basically free energy, free carbon energy. The energy that the machine uses, electricity, is obviously not been taken into account in terms of the carbon calculations. Now, all that might change because, as I showed in the slides, we're talking in places like Manchester and London about becoming completely net zero by 2040, 2050. So if that becomes a target, then that kind of energy will obviously have to be included as well. At this point in time, we're trying to get to net zero on the environmental systems. That's heating, hot water, ventilation, air conditioning, lighting, but not the plug loads, which obviously in a hospital are very high. Equipment efficiency is improving, but we need to look at individual items of equipment and also systems and start applying those. And I think when you look at existing buildings, that's a major place to start because they tended to stick with their old systems, they patch them up, maintain them, keep them going. But in effect, they're using far too much energy, and we can pick up or we can install much better modern equipment that will reduce energy. A prime example here in the UK in medical care homes is the use of cooling in the building for specific areas and also cooling for cold rooms and the like. We can pick up the heat from that to preheat hot water, and we found that kind of application reduces the hot water demand by 90%. So virtually getting free hot water all year round by recovering heat from refrigeration cooling circuits, VRV systems and the like. That's not commonly done, but that's a kind of a new system. And if you like, new equipment that's dramatically improving energy efficiency. So there's quite a few examples like that around. I did show information on geothermal there, and that's not widely applied in the UK at the moment, but there is quite a lot of energy underground. There's the hydrology and the geothermal information is good in the UK, so we can see where water is and where the rock layers are. And we could, using heat pumps and the like, pick up that heat and put it into our hospitals to reduce their energy load. So that, of course, is using electricity. The COP of a heat pump can be quite high in that situation. So water to water recovery system could be 5 to 1 or 6 to 1, as opposed to air, where the lower air temperatures might drop to 3 or 2 to 1. So that would be advantageous. And then as we move towards a decarbonised grid, which is a long-term aim in the UK and for many countries, the primary electricity we use is zero carbon. So we then get that multiplying factor where we recover the energy from underground. So if it's a COP of 5 to 1, we're getting the 5 plus the 1 unit of energy as complete zero carbon. And have another question here. How far back does the carbon count go? Will it include the inherent pollution in the equipment, the energy used to make it before it is installed? Well, definitions haven't gone that far at the moment, but the BRE have done quite a lot of work into embedded carbon, embedded energy, and the carbon required to make products. And there is information on that. And the UK building regulations were looking to bring that in, but it's actually a fairly complex process. So at the moment, they've backed off from doing that, and the EU directive as well. But in the long run, of course, we would have to think about that, because if we're trying to be totally zero carbon, then we have to look all the way back down the line. But I did some work on this some while back and looked at it in terms of housing, not a hospital, but I think the same would apply. If you, for example, decided to demolish an inefficient hospital and build a brand new one that was completely zero carbon, very well insulated, all the new products, the embedded energy, the embedded carbon would take 25 years to make up for the fact that you built this new one. So it's not a simple fix to just knock down old and build new. We really have to take our old buildings and improve them, because the embedded carbon is there already, and if we start afresh, then we're creating more embedded carbon. So this is a good question, really, because it's beginning to ask us what is the best strategy, just to demolish and start again, or is there an intervention in the existing building, or basically should we just plug renewable energy in and make up for a building being bad? And of course the answer is somewhere between, depending on the particular hospital we're looking at and all the other factors that go with that. So yes, in the long run we will have to look at the bigger amount of carbon being produced. That includes transportation aside, of course, and those kind of things. But materials like bricks, which require a lot of energy to produce, would be high carbon content. Things like steel, of course, are high carbon. But we struggle at the moment to get those into the design to decide what solution to actually adopt purely on a carbon basis. But that's a good question. That. I think some of the other things I showed in the slides was where do we have opportunities around to reduce carbon, such as those coal mines in Glasgow with the hot water in. And whilst that seems like a rather large step to take, you then look at what they've done in Toronto, using Lake Ontario to cool Toronto if you like, free of charge, or certainly zero carbon, by taking cold water from the lake. It's a scheme which started 20 years ago, and it's now installed and working very successfully. So we maybe need some really big thinking here in the UK and other countries, which takes us down a new path and allows us to take opportunities like that into account. I think we've also got to look at the practices, as I said, in the UK, where we have full fresh air. That's still fairly dominant. HTMO3 is about to go out for consultation again, and the NHS are updating it. So here's an opportunity to look at whether we should change our practices and do what they do in other countries, which is to recirculate 80% of the air. Obviously, we need enough fresh air, but we don't need 100%. We might do in specific areas, by the way, but in many areas of hospital we could do with a lot less, and that's really what we did at the scheme in Newcastle that I showed you, which reduced energy there. The aim wasn't to reduce energy, it was something we had to do. And then I think the other area is maybe looking at UV for air filtration, which we don't do in the UK. Maybe the Department of Health has done some work on that, actually, and it has been shown to be effective, but it's not liked at the moment. So we maybe need to do some demonstration-style projects to show that it can be effective. And then we are sterilising the air as it goes down. So another question has been raised. I would assume the most carbon neutral hospital is no hospital at all. Is caring for people outside hospital also part of the equation, for example, at home? Well, yes, certainly that is something we're doing more. If we look at well-being and mindfulness, we can effectively keep people fitter, healthier, and reduce the load on hospitals. That would certainly work. Once we move towards using a hospital, we will have to have hospitals, of course. It's what kind of hospital we have, how they interact with people, and how we can do that in a carbon neutral way. There's still transportation to take into effect. People have to travel to the hospital, the staff work there, and consequently there's carbon around that. But just to be clear about the zero carbon target, the 2050 target that all governments seem to be talking about. This is coming out of the Paris Initiative. They are talking about a zero carbon planet. And the IPCC, who are the intergovernment panel on climate change, are saying that we really need as a planet to be zero carbon before 2040. Otherwise, the impacts that are taking place are irreversible and will go beyond a tipping point. So hospitals are part of that. They're big energy users, but I think they can also sit in the community and be part of the zero carbon solution. So I think with that we're out of time. Unless anyone's got any more urgent questions, I think I'll conclude the webinar, and thank you all very much for taking part, and look forward to the next one. But please watch this space, because as I said, we are looking at a net zero hospital guide being produced in the next 6 months from ASHRAE. It'll be a relatively short guide, about 50 pages long, using this European work through REVA and Dutch colleagues. I have a meeting in Rotterdam at the end of the month to help develop that, and that should be available through ASHRAE next year and through REVA, which is the European body representing engineers. And then we'll look to follow that up with a more detailed guide in the future. I have a final question here. Can hospitals be designed to allow for increased wind speed around the building to put a wind farm so they generate their own energy? I don't think the hospitals themselves can. And I think in terms of any renewable energy, you would look to find the right place to locate these things. So in the UK, the best positions for wind turbines are on the coast or in the sea, but we can then cable them up to a grid and get that energy to our hospital. Putting it at the hospital may not be the most effective place. Now, one of the low energy hospitals that's built by the Department of Health in the 1990s was up at Hexham, and that was a demonstration type hospital. It's operational, of course, it's working, and that used a large wind turbine as its renewable energy source. So there is some information on that available, but I think the general feeling around wind turbine locations is to find the most viable position, which is probably not next to the hospital, and then pay for that, and then take the benefit of that into account with your calculations when you're looking at your carbon emissions from the hospital. So that's, in a way, contributing financially to a situation where the wind turbine is most efficient and most productive, rather than putting it on your building. As a general rule, it's my opinion, by the way, don't put wind turbines on buildings. They do create a lot of vibration, but either nearby or in a best wind location. And so I think we're running out of time now, so I'm going to have to conclude the webinar. And if anyone wants to send any further questions in, then I'll respond. But I'm going to close the webinar now. So thank you very much for taking part, and look forward to hearing you at the next one. Thank you.